Hello, my friend, and welcome to Stellar Sleep Stories. I'm so glad you're here with me tonight, settling in for another journey through the cosmos together. Tonight, we're going to explore something truly extraordinary, the loneliest places in the universe. These are the vast, quiet spaces where silence stretches for billions of miles, where a single atom might drift for thousands of years without meeting another, where emptiness itself becomes almost tangible. There's something deeply peaceful about these cosmic voids, something that mirrors the quiet we seek when we close our eyes at night. In these places, the universe whispers its softest secrets, and tonight we'll listen together. Before we begin our journey into these serene depths of space, I'd love to hear from you. What draws you to the quiet corners of the cosmos? What peaceful places do you dream about when you're drifting off to sleep? You can share your thoughts in the comments below. I read every single one, and they inspire these nightly journeys we take together. So, let's prepare for tonight's voyage. Find that perfect position where your body feels completely supported. Maybe you're already there, wrapped in your favorite blanket, your head nestled into that familiar spot on your pillow where everything feels just right. Take a breath with me, nice and easy. There's no special way you need to breathe tonight, just your natural rhythm, in and out. That's perfect. Feel how your body naturally knows what to do, how it settles a little deeper with each breath. Your shoulders might drop just a bit, your jaw might soften. Everything's beginning to slow down, to quiet down, just like the vast spaces we're about to explore. Tonight's journey is different from our usual adventures. We won't be visiting bright stars or bustling galaxies. Instead, we're drifting into the spaces between, the enormous gaps in the cosmic tapestry where emptiness reigns supreme. These are places of profound stillness, where time seems to stretch and slow, where the usual rules of busy, crowded spaces don't apply. Out here, in the loneliest reaches of the universe, we'll discover a different kind of beauty, the beauty of absolute peace. We'll float through cosmic voids that span billions of light years, visit rogue planets that wander alone through eternal darkness, and drift in the incomprehensible emptiness between galaxy clusters, where space is so vast and so empty that it challenges our very understanding of what nothing means. You know, when we look up at the night sky from Earth, it seems so full of stars. But that's an illusion created by our perspective. The truth is that the universe is mostly empty space, overwhelmingly, incomprehensibly empty. If you were to take all the matter in the observable universe, every star, every planet, every speck of dust, and spread it out evenly, you'd have about 1 hydrogen atom in every 4 cubic meters of space. That's like finding a single grain of sand in a volume larger than a house. But the universe isn't spread out evenly. It's clumped together in a vast cosmic web, with galaxies strung along invisible filaments of dark matter. And between these filaments, that's where we find the true voids, the loneliest places that exist. Some of these voids are so large that light itself, traveling at 186,000 miles per second, would take hundreds of millions of years to cross them. In these spaces, you could travel for lifetimes and never encounter a single star, a single planet, even a single particle of dust. Yet there's something hauntingly beautiful about these empty places. They're not just absences, they're presences of a different kind. They hold the quiet that existed before the first stars were born. They carry the peace that will remain long after the last star fades. Tonight, we'll visit these places together, starting close to home, at the lonely edge of our own solar system, then drifting farther and farther out into spaces so vast and empty that they make even our imagination feel small. But don't worry, you're safe here with me. We're just observers tonight, floating in perfect comfort through these peaceful voids, letting their quietness wash over us, letting their stillness slow our thoughts. So, close your eyes if you haven't already, or let them rest softly on nothing in particular, and let's begin our drift into the loneliest, most peaceful places in all of existence. Let's begin our journey at the edge of the familiar, out past Neptune, the last of the giant planets in our solar system. You're floating now about 3 billion miles from the Sun. That's 30 times farther from our star than Earth is. Out here, the Sun looks different than you've ever seen it. It's still the brightest star in the sky, but it's no longer that overwhelming presence we know. It's become just a very bright point of light, like Venus looks from Earth on a clear evening. The temperature here hovers around -370 degrees Fahrenheit, just about 60 degrees above absolute zero. But in our journey tonight, you don't feel that cold. You're perfectly comfortable, perfectly protected, just observing this lonely frontier. This is where our solar system begins to fade into something else, something quieter. The 8 planets are all behind you now. Even Neptune, with its deep blue clouds and fierce winds, is millions of miles away. Out here, you've entered what astronomers call the Kuiper Belt. Though belt makes it sound crowded, it's not. It's a vast ring of icy bodies and dwarf planets. But they're scattered so far apart that if you were standing on one, you wouldn't be able to see another with your naked eye. Pluto lives out here, our once 9th planet, now reclassified but no less fascinating. It takes Pluto 248 Earth years to orbit the Sun just once. Imagine that! If you were born on Pluto, you wouldn't even live long enough to see a single birthday. But even Pluto has company compared to where we're heading. It has its moon, Charon, locked in an eternal dance. They face each other always, tidally locked, never looking away. There's something poetic about that. Two bodies in the loneliness of space, at least having each other. As you drift outward, past Pluto's orbit, the spaces between objects grow even larger. There's Eris, Make, Sedna, lonely dwarf planets whose names most people have never heard. They float out here in the darkness, following their slow, patient orbits. Sedna is particularly isolated. Its orbit takes it so far from the Sun that it needs 11,400 years to complete just one trip around our star. When Sedna was last in its current position, humans had just discovered agriculture. The pyramids wouldn't be built for another 6,000 years. The sunlight out here is so faint, about as bright as a full moon on Earth. You could read by it, but just barely. Colors fade to shades of gray. Everything becomes monochrome, muted, quiet. And it's so empty. The space between objects out here is staggering. If the solar system within Neptune's orbit was the size of a quarter, a single US quarter coin, then the Kuiper Belt would stretch out to the size of a football field. And in all that space, the actual objects, the dwarf planets and asteroids and comets, would be like scattered grains of sand. NASA's New Horizons spacecraft passed through here. After visiting Pluto in 2015, it continued outward, flying through this emptiness at over 36,000 miles per hour. And even at that incredible speed, it took years to reach its next target, a tiny object called Arrokoth, just 22 miles across. Think about that for a moment. Flying faster than any human-made object has ever traveled, and it still takes years to get from one tiny island to another in this vast, dark ocean. The silence out here is absolute. There's no air to carry sound, no wind, no weather. Just the slow, silent dance of ice and rock in the darkness. These objects have been circling out here for 4.5 billion years, and they'll continue their lonely orbits for billions more. Yet there's a strange peace in this isolation. These distant objects don't rush. They don't compete for space. They simply exist, following the gentle pull of gravity, patient and eternal. As you float here at the edge of our solar system, you can feel how the Sun's influence is weakening. Its gravity still reaches out here, still holds these distant objects in thrall, but barely. Just a whisper of force, a suggestion rather than a command. And beyond this, beyond the Kuiper Belt, the loneliness deepens even more. Now we're drifting farther, much farther, leaving the Kuiper Belt behind and entering a realm that no spacecraft has ever explored. No telescope has ever directly seen. Welcome to the Oort cloud. You're now about 1 trillion miles from the sun. That's 1,000 billion miles. If you could somehow travel at the speed of light, 186,000 miles per second, it would take you nearly 2 months to get here from Earth. The Oort cloud is almost impossible to comprehend. It's a vast spherical shell of icy bodies surrounding our entire solar system, stretching from where we are now all the way out to perhaps 2 light years from the sun. That's halfway to the nearest star. Imagine you're floating in a sphere so large that light itself needs 2 years to cross it. And scattered throughout this incomprehensible volume are perhaps trillions of chunks of ice and rock, the raw materials of comets. But scattered doesn't begin to describe how lonely these objects are. If you were standing on one of these icy bodies right now, the nearest neighbor might be as far away as Earth is from the sun. 93 million miles of absolute emptiness between you and the next tiny island of matter. And these aren't planets or even asteroids. They're mostly small chunks of ice, many no bigger than mountains. The sun from here, our mighty star that brings life to Earth, is just another star in the sky. You couldn't even tell which one it is without careful measurement. It provides no warmth here, no light to speak of. Its gravity is just the faintest suggestion, barely enough to keep these distant objects tethered. This is where comets are born, or rather, where they sleep. These chunks of ice have been out here since the solar system formed, pristine and unchanged, waiting. Sometimes, very rarely, something disturbs one of them. Maybe the gravity of a passing star, maybe the cumulative effect of galactic tides. And when that happens, one of these sleeping comets begins a long, long fall toward the sun. It might take millions of years for that journey. Millions of years of slowly picking up speed, slowly brightening, until finally it swoops past the sun and puts on that glorious display we see from Earth. The bright tail streaming across our sky started here, in this lonely, dark place. Halley's Comet, which visits Earth every 76 years, it spends most of its time out here in the cold and dark. When it's at its farthest point, it's beyond Neptune, alone in the darkness for decades before beginning its journey back to the inner solar system. The isolation here is profound. These objects have been drifting in the darkness for billions of years. They've never known warmth, never known light beyond the faint glow of distant stars. They exist in a perpetual night that makes the darkest places on Earth seem blazingly bright by comparison. The temperature here is about minus 455 degrees Fahrenheit, just a few degrees above absolute zero. the coldest temperature possible. At this temperature, even atoms slow down. Everything moves in slow motion. Time itself seems to stretch. And the emptiness. The emptiness is overwhelming. If you took all the objects in the Oort cloud, every chunk of ice, every proto-comet, and added them all together, they'd probably make up only a few times the mass of Earth. Spread that across a sphere 2 light years wide, and you begin to understand what true emptiness means. You could drift here for a human lifetime and never encounter a single object. You could shine the brightest searchlight, and its beam would fade to nothing without ever illuminating anything. This is isolation on a scale that our minds weren't designed to comprehend. Yet these lonely sentinels serve a purpose. They're the guardians of our solar system's history, frozen time capsules from the birth of our planets, waiting in the darkness, patient and eternal. Some astronomers call the Oort cloud the solar system's deep freeze. But it's more than that. It's the boundary, the membrane between our sun's realm and the true vastness of interstellar space. And that's where we're heading next, beyond even this lonely cloud, into the space between the stars themselves. We're leaving the Oort cloud behind now, drifting beyond the last vestige of our sun's influence. You're crossing a boundary that only 2 human-made objects have ever crossed, the Voyager 1 and Voyager 2 spacecraft. Welcome to interstellar space, the void between the stars. Voyager 1 crossed this threshold in 2012 after traveling for 35 years. It's now over 15 billion miles from Earth and still going, still sending back whispers of data across that impossible distance. Though its signal is so faint now, so weak, that all the radio telescopes on Earth have to work together just to hear it. Out here, you've entered a different realm entirely. The solar wind, that stream of particles flowing from our sun, no longer reaches you. You're in the space between stellar neighborhoods, where no star holds sway. The nearest star to our Sun is Proxima Centauri, 4.2 light years away. That's about 25 trillion miles. If you could travel at the speed of Voyager 1, about 38,000 miles per hour, it would take you 70,000 years to get there. 70,000 years. When Voyager 1 was launched in 1977, NASA included a golden record, sounds and images from Earth, just in case someone or something might find it one day. But the truth is, Voyager won't come within even a light year of another star for 40,000 years. It'll drift through this emptiness, carrying its message from Earth, likely long after humanity itself has changed beyond recognition. The space you're floating through now is almost perfectly empty, but not quite. There are about 1 or 2 hydrogen atoms per cubic centimeter here. That might sound like something, but consider this. The air you breathe on Earth has about 30 billion molecules in the same space. This near vacuum is filled with something else though, cosmic rays, high energy particles streaming from distant supernovas, from black holes, from events so powerful and so far away that we can barely imagine them. These particles have been traveling for millions of years, crossing the void, carrying energy from catastrophes that happened when Earth was young. But even these cosmic rays are lonely travelers. They stream through space, without interaction, without collision, just racing through the darkness at nearly the speed of light. The darkness here is absolute. There's no scattered sunlight, no reflected glow from planets, just the pinpoint lights of stars, so distant they never seem to move. You could watch them for a human lifetime, and they'd appear frozen in place, like someone painted dots on a black ceiling infinitely far away. And it's quiet, so quiet. Not the kind of quiet you know on Earth, where there's always some sound, some vibration, even if you can't consciously hear it. This is the quiet of true vacuum, where sound cannot exist, where vibration has no medium. It's a silence so complete that if you could somehow survive here unprotected, you'd hear your own heart beating, your blood flowing, the tiny sounds of your body that are always masked by the noise of the world. Interstellar space is also ancient. The hydrogen atoms floating here, some of them have been drifting since shortly after the Big Bang, 13.8 billion years ago. They've never been part of a star, never been forged into heavier elements. They're pristine, primordial, older than our galaxy itself. Occasionally, very occasionally, this emptiness is disturbed. Sometimes a star dies in a supernova, and the shock wave ripples through interstellar space. But even these tremendous explosions, visible across millions of light years, become gentle by the time they reach here. The shock wave that could destroy planets becomes just a slight warming of the near vacuum, a gentle compression that passes through and continues on its way. Our solar system is actually moving through interstellar space right now. The Sun and all its planets are traveling together at about 450,000 miles per hour relative to the center of the Milky Way. We're riding through this void like a ship through a dark ocean. Our destination? We'll complete one orbit around the galaxy in about 225 million years. The last time our solar system was in this spot in its galactic orbit, dinosaurs ruled the Earth. As you float here in interstellar space, you might notice something strange. The stars aren't evenly distributed. There are streams and clusters, patterns that reveal the hidden structure of our galaxy. Dark lanes where dust blocks the light, bright knots where star formation is happening, even now, even in this moment. But mostly, there's just space. Vast, empty, patient space. The distance between stars in our galaxy averages about 4 light years. In the densest star clusters, they might be only a light year apart. In the spiral arms where we live, it's typically 4 to 5 light years. But in some regions, the gaps are much larger. 10, 20, even 50 light years of nothing. This is the ocean that islands of light float in. This is the canvas on which the universe paints its masterpieces. This emptiness isn't just the absence of things. It's the presence of possibility. The stage where cosmic dramas play out across billions of years. Now, let's visit one of the loneliest types of objects in the universe, a rogue planet. You're approaching a world that doesn't orbit any star. It's been drifting through interstellar space for perhaps billions of years, alone, dark, forgotten. Scientists estimate there might be billions, maybe even trillions of these rogue planets in our galaxy. Worlds that were either born in isolation or ejected from their home solar systems by gravitational interactions, cast out into permanent exile. The planet below you is about the size of Jupiter, a gas giant that once might have orbited a star much like our Sun. But something happened. Perhaps another star passed too close to its system. Perhaps a gravitational dance with other planets in its system went wrong. Whatever the cause, it was flung out, sent careening into the darkness. There's no sunlight here, hasn't been for eons. The only light comes from the distant stars, so faint that noon and midnight are meaningless concepts. The cloud tops below you are darker than the darkest night on Earth. They're probably still moving, still swirling in vast storms, but you can't see them. The only reason you can sense this world at all is its faint heat signature. It's still warm, still radiating the heat from its formation and from the slow compression of its massive bulk. Jupiter does the same thing, generating more heat than it receives from the sun. These rogue worlds can stay warm inside for billions of years, slowly cooling, slowly fading. Some rogue planets might have moons. Imagine that! Entire moon systems orbiting a dark world, dancing together through the void. If there were observers on such a moon, they'd see their parent planet as a black circle blocking out stars, a void within the void. Their sky would be eternally dark, except for the distant stars. Yet some scientists think life could exist on these worlds. Deep inside a rogue planet like this, the pressure and heat might maintain liquid water. There might be vast, dark oceans beneath miles of ice, heated not by a star, but by the planet's own internal fires, by radioactive decay, by tidal forces if it has large moons. In those pitch-black depths, life might swim, completely unaware that the universe exists, never knowing starlight, never knowing that their world is a lonely wanderer. They'd live their entire evolutionary history in darkness, generation after generation, eon after eon. The surface temperature of this rogue world is about -400 degrees Fahrenheit. Cold enough that gases we think of as permanent, like nitrogen and oxygen, would be frozen solid. Cold enough that even hydrogen becomes a liquid. Yet this planet continues its journey. It's moving at maybe 20 miles per second relative to the stars around it. But space is so vast that it might not pass near another star for millions of years. And when it does, it'll just sail by in the darkness, unnoticed, unremarked. These rogue planets are cosmic orphans. They remind us how precious our sun is, how rare and wonderful it is to orbit a star, to know warmth, to know light, to have seasons and days and the possibility of life as we know it. Some rogue planets are even lonelier. The smaller rocky worlds like Earth, if they're ejected from their systems, they cool much faster. Within a few million years, they become frozen balls of rock and ice. Their atmospheres freeze and fall as snow. Their oceans become solid ice all the way to the bottom. Any life that might have existed, gone. NASA's telescopes have actually detected some of these rogue worlds. Not by seeing them directly, they're too dark for that, but by watching for gravitational microlensing. When a rogue planet passes between us and a distant star, its gravity bends the starlight, making the star briefly brighten. It's a fleeting moment, lasting maybe a few days, when we know a dark world is out there. And then it's gone again, invisible, untrackable, continuing its eternal journey. The loneliness of these worlds is absolute. They'll never again know the warmth of a sunrise, never feel the gravitational embrace of a parent star. They're destined to wander until the universe itself grows cold, until the last stars burn out and everything becomes dark. Some astronomers call them orphan planets. Others call them nomad planets. But perhaps the most poetic name is planemo, planetary mass objects, worlds that are planets in every way, except one. They have no home. As you drift away from this dark world, leaving it to its solitary journey, you might wonder how many of these lonely planets you've passed without knowing. How many dark worlds are sailing through the void right now, carrying their secrets, their histories, their possibilities through the eternal night. Let's pull back now, way back, and look at the neighborhood our solar system lives in. You're floating above what astronomers call the local bubble, a vast cavity in our region of the Milky Way. It's about 1,000 light years across, and our sun sits near its center, like a single firefly in an enormous, dark cathedral. The local bubble is different from the space around it. It's emptier, much emptier. The usual interstellar medium has about 1 atom per cubic centimeter. But here in the local bubble, it's 10 times less dense. 1 atom per every 10 cubic centimeters. It's like finding an air pocket deep underwater, except this pocket is almost perfect vacuum, and it stretches for hundreds of light years in every direction. This cosmic void was carved out by supernovas. Millions of years ago, long before humans walked the Earth, massive stars exploded in our galactic neighborhood, one after another, perhaps 20 of them over the course of 10 million years. Their shock waves swept through space, pushing gas and dust outward, clearing this vast bubble. Those explosions are long finished now. The stars that died are just neutron stars or black holes, dark remnants drifting silently. But their legacy remains, this enormous emptiness that we call home. The walls of the local bubble are made of compressed gas and dust, pushed there by those ancient explosions. They glow faintly in X-rays, too faint for our eyes to see, but NASA's telescopes can detect them. These walls are like cosmic snowdrifts, where material has piled up, creating a boundary between our void and the denser regions beyond. Our sun has been traveling through this bubble for the last 5 to 10 million years. We entered it long before our species evolved, and will be inside it for millions of years to come. Our entire recorded history, every human who ever lived, has existed inside this cosmic void. The emptiness here is protective in a way. With less gas and dust, harmful radiation can't build up as easily. Cosmic rays pass through more freely instead of creating secondary radiation. It's like living in a cosmic clean room, where the usual interstellar weather can't reach us. But it also means we're isolated. The nearest star-forming regions are at the edges of the bubble, hundreds of light years away. We can see them in our telescopes, the Orion Nebula, the Scorpius-Centaurus Association, places where new stars are being born right now. But they're so far away, separated from us by this vast emptiness. As you float here, looking at the local bubble, you can see other bubbles too. The galaxy is full of them. Swiss cheese made of stars and gas, with vast cavities blown by stellar winds and supernovas. Some bubbles are connected, forming enormous tunnel systems through the galaxy. Rivers of emptiness flowing between islands of stars. Our neighbor is the Loop I bubble, another vast cavity that touches ours. Where they meet, there's a tunnel, a corridor of emptiness connecting one void to another. If you could travel through it, you'd journey hundreds of light years without encountering anything denser than a whisper. The local bubble is so large that light takes 1,000 years to cross it. 1,000 years. When light from a star on one side of the bubble started its journey to the other side, Vikings were sailing the North Atlantic. The Maya civilization was at its height. And that light is still traveling, still crossing this emptiness, carrying its message across the void. Inside this bubble, stars float like distant lanterns. There's Sirius, the brightest star in our night sky, just 8.6 light years away. There's Alpha Centauri, our nearest neighbor, Vega, Altair, Fomalhaut. Each one isolated in the emptiness, each one surrounded by vast spaces of almost nothing. The silence here is deeper than in normal interstellar space. With less material to interact with, fewer atoms to collide, fewer particles to create even the faintest whisper of activity. It's a quiet that's been growing for millions of years, deepening with each passing epoch. Sometimes, very rarely, a star passes through the bubble. These stellar visitors drift through like ships in the night, taking hundreds of thousands of years to cross. Right now, there's a star called Gliese 710 approaching. It'll pass through the outer reaches of our solar system in about 1.3 million years. Close enough to disturb the Oort cloud, but still so far away, it'll just be a bright star in Earth's sky. The local bubble breathes. Not quickly, not in any way we could notice, but over millions of years, it expands and contracts. The walls pulse slowly outward as the pressure changes. New supernovas in nearby regions send gentle shockwaves through, causing the bubble to ring like a vast silent bell. This is our cosmic home, this emptiness, this void. We live in one of the quieter regions of the galaxy, and that quietness, that isolation, might be one reason life could evolve here, undisturbed, protected, given time to develop in peace. Now we're approaching something different, something that's empty in another way entirely. Ahead of you is a dark nebula, what astronomers sometimes call a dark cloud. It looks like a shadow against the stars, a place where the lights go out. This is Barnard 68, about 500 light years from Earth. It's a cloud of dust and molecular gas so thick that no visible light can pass through it. Behind this cloud, there might be thousands of stars, entire stellar systems, but we can't see them. They're hidden behind this cosmic veil. The cloud is about half a light year across, seems small compared to the voids we've explored, but it contains enough material to make several stars like our Sun. All that matter compressed into this dark cocoon, waiting. Inside Barnard 68, the darkness is absolute. If you could drift into its heart, the stars would disappear one by one. First the faint ones, then the bright ones, until finally even the blazing light of nearby stars would fade to nothing. You'd be surrounded by opaque walls of dust, floating in a darkness more complete than anything that exists on Earth. The temperature inside is barely 16 degrees above absolute zero, minus 429 degrees Fahrenheit. It's so cold that most molecules have slowed almost to a stop. They drift lazily through the darkness, occasionally bumping into each other, sticking together, growing. This is one of the loneliest places for light itself. Photons that enter the edge of the cloud are absorbed almost immediately. They warm a dust grain by an impossibly tiny amount, and their journey ends. Light that has traveled for perhaps millions of years across space stops here, trapped in the darkness. But dark nebula like this are also stellar nurseries, or rather, they will be. Right now, Barnard 68 is stable, quiet. The pressure of the gas inside balances the pull of gravity. It's been floating like this for perhaps 200,000 years. But soon, in cosmic terms, something will change. Maybe a shock wave from a distant supernova. Maybe the gravity of a passing star. Maybe just the slow accumulation of more material. Something will tip the balance, and the cloud will begin to collapse. When that happens, this dark, lonely cloud will transform. Gravity will pull the material inward. The center will heat up. Pressure will build. And eventually, perhaps in 100,000 years, a new star will ignite in the darkness. But for now, it waits. Silent, dark, patient. There are thousands of these dark nebula scattered through our galaxy. You can see them on clear nights if you know where to look. Dark patches in the Milky Way where the stars seem to disappear. The Coal Sack Nebula, the Horsehead Nebula, the Snake Nebula. Each one a cosmic shadow, a lonely pool of darkness in the river of stars. Some dark nebula are enormous. The Aquila Rift is a complex of dark clouds stretching for hundreds of light years. It blocks our view of the galactic center, creating a great dark lane across the sky. Inside this vast complex, there might be millions of solar masses of material, all of it dark, all of it cold, all of it waiting. Native American astronomers knew these dark clouds. They saw them as constellations of darkness. The Inca saw a llama, a serpent, a toad in the dark patches of the Milky Way. They understood that darkness could be a presence, not just an absence. Inside these clouds, complex chemistry happens in the darkness. Water forms on dust grains. Methane, ammonia, even simple organic molecules. The building blocks of life, assembling themselves atom by atom in the cold and dark, protected from radiation, shielded from the chaos of space, given time to grow complex. Some of the molecules in your body right now, the carbon in your DNA, the iron in your blood, they might have formed in a dark nebula like this, billions of years ago, before our sun was born. As you float near Barnard 68, you notice something subtle. Around its edges, the darkness isn't complete. There's a faint reddening of the starlight that manages to pass through the thinner regions. Like sunset through Earth's atmosphere, but stretched across light years. The cloud acts like a cosmic filter, letting through only the longest wavelengths. In infrared light, which our eyes can't see, the cloud glows faintly. All that absorbed starlight has to go somewhere. It warms the dust grains just slightly, and they radiate that heat as infrared. It's like the cloud is remembering all the light it's absorbed, holding those memories as the faintest possible warmth. These dark nebula are islands of material in the emptiness, but they're also islands of isolation. Inside them, you're cut off from the rest of the universe. No starlight reaches you, no cosmic rays, no solar winds. You're wrapped in a cocoon of darkness that might last for millions of years. Yet this isolation serves a purpose. These are the universe's quiet workshops, where gravity and chemistry work undisturbed, where the slow processes of star formation can proceed without interruption. The darkness here isn't empty, it's full of potential, full of futures not yet realized, stars not yet born, planets not yet formed, perhaps even life that won't exist for billions of years. But for now, in this moment, there's just the darkness, patient and profound, waiting in the spaces between the stars. We're pulling back even further now, drifting up and out, until you can see the entire structure of our galaxy spread below you. The Milky Way, our home, a spiral of light containing 400 billion stars. And from here, floating above it all, you can see its true shape. Those beautiful spiral arms, the Sagittarius arm, the Perseus arm, the Scutum Centaurus arm. They glow with the light of young, hot stars, regions where gas clouds collapse, where new suns are born, where the galaxy is active and alive. But between those arms, Between those arms are vast spaces, quieter spaces, lonelier spaces. Our solar system actually lives in one of these quiet zones. We're positioned between the major spiral arms, in a small spur called the Orion Arm. But really, we're in the cosmic suburbs, the quiet outskirts where not much happens. And that's perfect for us, perfect for life. The spaces between spiral arms are like cosmic doldrums, regions where the density waves that create the arms have passed by, leaving calmness in their wake. The star formation here slowed down millions of years ago. Things are settled, peaceful. As you drift through these inter-arm regions, the darkness deepens. There are still stars here, older stars, quieter stars, stars that formed long ago and now just drift, burning steadily, patient yellow and orange suns that will shine for billions of years more. No drama, no massive blue giants that live fast and die young, just quiet persistence. The space between stars is larger here too. In the spiral arms, stars might be only a few light years apart, clustered together in stellar associations. But out here, in the spaces between, the gaps stretch wider. 5 light years, 10, 15. Each star more isolated, each one a lonelier island of light. It takes the Sun about 225 million years to orbit the galaxy once, what astronomers call a galactic year. And in that journey, we pass through spiral arms and then back out into these quiet zones, like a cosmic rhythm, in and out, active and quiet, crowded and lonely. The last time our solar system was passing through a major spiral arm, the continents on Earth were just beginning to break apart. Life was recovering from the largest mass extinction in history. Everything we know, everyone who has ever lived, has existed during this quiet phase between the arms. These quiet zones are protective. When solar systems pass through the dense spiral arms, they encounter more radiation, more supernovas, more gravitational disruptions. But here, in the spaces between, it's calmer, safer. The cosmic rays are gentler here, the stellar winds quieter. It's like finding a sheltered cove in a vast ocean where the waves don't reach, where you can rest. As you float here, looking down at the galaxy, you notice how most of it is actually these quiet spaces. The bright spiral arms that we see in photographs, they're just the highlighted edges, like foam on ocean waves. The majority of the galaxy's volume is these darker, quieter regions, these spaces between. Time moves differently here, or seems to. Without the constant stellar fireworks of the spiral arms, without new stars being born every few million years, these regions feel ancient, unchanging. Stars here have been burning steadily for billions of years, and will continue for billions more. The darkness between the stars here has a different quality. It's not the aggressive darkness of a dark nebula blocking light. It's not the empty darkness of a void. It's a settled darkness. A darkness that has found its equilibrium, that isn't trying to become anything else. Sometimes a star from the spiral arms gets ejected, flung out by gravitational interactions, and it arrives in these quiet zones like a visitor from another world, younger, hotter, burning with a different fire. But eventually, even these visitors settle down, slow down, join the quiet drift. Our sun will stay in this quiet zone for millions of years more, drifting between the arms, carrying Earth and all the planets with it. And maybe that's why life could evolve here, why complexity could arise. Because we've had time, quiet time, undisturbed time. In the spiral arms, the radiation from massive stars can strip away planetary atmospheres. The gravitational chaos can destabilize orbits. But here, in the spaces between, everything is stable, quiet, safe. You're floating in one of the universe's quiet rooms, where the cosmic noise drops to a whisper, where the great engines of star formation idle, where time stretches out like a long, peaceful afternoon. Now we're leaving our galaxy entirely. You're rising up, up, away from the Milky Way, watching it shrink below you. 400 billion stars becoming a single smudge of light. And then, even that begins to fade into the distance. Welcome to intergalactic space, the ocean between island universes. The nearest major galaxy to us is Andromeda, 2.5 million light-years away. Between here and there is almost nothing. A few dwarf galaxies, some scattered stars that were torn from their homes, some dark matter we can't see, but mostly incomprehensible emptiness. The scale here is beyond imagination. If the entire Milky Way galaxy, with its 400 billion stars, was shrunk down to the size of a dinner plate, then Andromeda would be another dinner plate about 6 feet away. And between them, almost nothing, just empty space. The density of matter in intergalactic space is almost zero. Maybe 1 hydrogen atom per cubic meter. That's 1,000,000 times less dense than typical interstellar space. It's a vacuum so perfect that scientists on Earth can't recreate it, even with our best technology. As you float here, halfway between the Milky Way and Andromeda, you're in one of the loneliest places imaginable. Behind you, Our galaxy is just a fuzzy patch of light, like a distant city seen from a mountaintop. Ahead, Andromeda is another faint smudge. To the sides, a few smaller galaxies of the local group, but they're even fainter, even farther. The darkness here is profound. It's not just the absence of nearby stars, it's the absence of almost everything. There's no dust to scatter light, no gas clouds to glow, just emptiness stretching in every direction for millions of light years. Light from the Milky Way takes 1.25 million years to reach you here. The light you're seeing from our galaxy left when early humans were just learning to use fire. The light from Andromeda is even older. When it started its journey, Earth was in an ice age. You're looking at the past, always the past, never the present. Sometimes, rarely, a star passes through here. Hypervelocity stars, ejected from their galaxies by encounters with supermassive black holes. They race through intergalactic space at hundreds of miles per second. But even at those speeds, they'll take millions of years to reach another galaxy, if they ever do. Most will just drift, forever, alone in the darkness between galaxies. These lonely stars might have planets. Imagine living on a world orbiting one of these intergalactic wanderers. Your sky would have no Milky Way, no band of light across the heavens, just your single sun, and, in the very best conditions, a few faint smudges that are actually entire galaxies. The universe would seem so empty, so quiet, so vast. Yet even this emptiness isn't truly empty. Dark matter flows through here. Invisible rivers of something we don't fully understand. It shapes the paths galaxies take. It provides the hidden scaffolding of the universe, but we can't see it, can't touch it, can only infer its presence from the way galaxies move. Cosmic rays streak through this void too. Particles accelerated to nearly the speed of light by distant quasars, by galaxy collisions, by events so powerful they reshape entire clusters of galaxies. These particles have been traveling for millions, maybe billions of years, crossing the void, carrying energy from one island universe to another. The temperature here is about 2.7 degrees above absolute zero. That's the temperature of the cosmic microwave background, the faint afterglow of the Big Bang itself. It fills even this emptiness with the faintest possible warmth, a whisper of heat from when the universe was young and hot and dense. In about 4 billion years, The Milky Way and Andromeda will begin to merge. Right now, they're approaching each other at about 70 miles per second, drawn together by gravity across the void. That sounds fast, but space is so vast that it'll take billions of years for them to meet. When they do finally collide, it won't be violent. The spaces between stars are so large that the two galaxies will pass through each other like ghosts. Stars won't collide, they'll just dance around each other, finding new orbits, new patterns. The night sky will change, but slowly, gently. For now, though, there's just the void, this immense ocean of nothingness, where entire galaxies float like islands, where light takes millions of years to travel from one shore to another, where the silence is absolute and the darkness is profound. You could drift here for 1 trillion years, and space would look almost the same. The galaxies would be in slightly different positions. Some would have merged, some would have drifted apart. But the vastness, the emptiness, the profound isolation, that would remain. This is solitude on a scale that makes even the loneliest places in our galaxy seem crowded. This is the universe between the universes, the space between the spaces, where emptiness reaches its most perfect expression. And yet, even here, you're not truly alone. Every particle of your being is connected to this vastness. You're made of atoms forged in stars, which were born in galaxies, which float in this void. You're part of it all, even here, even in this incomprehensible emptiness. The universe is vast and quiet and lonely, but you belong to it, and it, in its own silent way, belongs to you. And now we drift even deeper into the emptiest places that exist, the cosmic voids. These are regions so vast, so empty, that they challenge our understanding of what nothingness means. Below you stretches the Buttes void, sometimes called the Great Nothing. It's one of the largest voids we've discovered. 330 million light years across. Can you imagine that? 330 million light years of almost nothing. If you could travel at the speed of light itself, the fastest speed possible in our universe, it would take you 330 million years to cross this emptiness. When you started your journey, Earth's continents would be unrecognizable. Life would be completely different. And when you finished, if Earth still existed, nothing you knew would remain. Inside this void, galaxies are rare, so rare. Where normal space might have thousands of galaxies, the Buttes void has only about 60. 60 galaxies in a space that could hold thousands. They're scattered along tube-like regions, lonely lights following invisible paths through the darkness. The emptiness here is different, deeper. It's not just the space between galaxies, it's the absence of galaxies themselves. Vast regions where matter never clumped together, never formed stars, never created the islands of light we're familiar with. You're floating now in the heart of this void. The nearest galaxy might be 50 million light years away in any direction. You're surrounded by a sphere of emptiness so large that even traveling at impossible speeds, you'd grow old, die, and turn to dust long before reaching anything. The darkness here is absolute, profound, total. There are no nearby stars to light the void, no galaxies to paint the darkness with their glow. Just emptiness, stretching and stretching and stretching. Scientists think these voids formed very early in the universe. Tiny quantum fluctuations in the first moments after the Big Bang became the seeds of structure. Where matter was slightly denser, it pulled in more matter, forming galaxies and clusters. Where it was slightly less dense, it became emptier and emptier until these vast voids formed. The voids are still growing. Even now, even as you float here, the void is expanding. Matter is flowing away toward the edges, leaving the center ever emptier, ever lonelier, ever quieter. It's like the universe is breathing very, very slowly. The voids expand, the walls between them compress. Galaxies cluster along filaments, while the voids grow ever larger. A cosmic rhythm playing out over billions of years. The temperature here is barely above absolute zero. There's nothing to hold heat, nothing to generate warmth, just the faint, faint echo of the Big Bang, that 2.7 degree whisper that fills all of space. Even that seems quieter here, more distant. If you could survive here, floating in this void, time would seem to slow. With no references, no changes, no events to mark the passage of moments, your mind would drift. Your thoughts would stretch, become longer, quieter, softer. The silence here is perfect. No cosmic rays disturbing the peace. No stellar winds whispering through space. No gravitational waves rippling the fabric of space-time. Just stillness, absolute stillness. Some cosmologists call these voids the true structure of the universe. Not the galaxies, not the clusters, but the voids. The emptiness defines the shape of everything. Like the holes in Swiss cheese are what give it its character. The voids are the dominant feature, and everything else, all the light and matter and energy, exists in the thin walls between them. You could fall asleep here so easily, with nothing to disturb you, nothing to pull your attention. Your thoughts would naturally slow, naturally quiet, like a wheel that stopped being pushed, gradually, gently coming to rest. The Bootes void has a few galaxies arranged in a tube. Astronomers call it the Bootes void galaxy tube. These few dozen galaxies stretched along a narrow path through the emptiness, like breadcrumbs in a vast forest, or islands in an infinite ocean. But even these galaxies are quieter than normal, with no neighbors to interact with, no nearby galaxies to exchange gas and stars with. They evolve slowly, peacefully. Their stars form at a leisurely pace. Their spiral arms wind slowly. Everything happens in slow motion. As you drift through this void, you might notice you're not truly alone. Dark matter is here, invisible, intangible, but present. And neutrinos, ghost particles that barely interact with anything. Billions passing through you every second, unseeable, unfelt, carrying messages from distant corners of the universe. But these are quiet companions. They don't disturb the peace, don't break the silence. They're just there, part of the emptiness, part of the vast, quiet darkness. The voids are where the universe rests, where it takes a breath between the busy work of star formation, where it pauses between the drama of galactic collisions, where it finds its peace, its stillness, its perfect, quiet calm. And you can rest here too, floating in this cosmic quietness, letting the vastness hold you, letting the silence embrace you. There's nothing you need to do, nowhere you need to go. You can just drift and rest and be. We've come to the very edge now, the farthest place we can see, the boundary of everything we can know. You're floating at the edge of the observable universe, 46.5 billion light years from Earth. This might seem confusing. The universe is only 13.8 billion years old. So how can we see 46.5 billion light years away? It's because space itself has been expanding, stretching, while the light traveled toward us. The most distant light we can see has been traveling for nearly the entire age of the universe. Beyond this edge, there's more universe. We know it's there, it must be there, but we can never see it. The light from those regions hasn't had time to reach us yet, and because the universe is expanding, accelerating, Some of it never will. You're standing at the ultimate boundary between the known and the unknowable. The galaxies here, at this incredible distance, appear as they were when the universe was very young, just a few 100 million years old. You're looking at baby galaxies, the first lights in the darkness, small, primitive, just beginning their long journey to become the massive galaxies we see today. But here's the profound loneliness. These galaxies you're seeing, they don't exist anymore. Not like this. They've evolved, changed, merged with others. Maybe they're part of giant elliptical galaxies now. Maybe they've been torn apart. The light you're seeing is ancient history, ghosts of what once was. And they can't see you. If someone in those distant galaxies looked in your direction right now, they wouldn't see you. They wouldn't see the Milky Way. They wouldn't even see the atoms that would eventually become our galaxy. We didn't exist yet when the light you're seeing left them. This is the loneliness of time itself. You're isolated not just by space, but by the structure of space-time. You can never interact with what you're seeing, never visit, never communicate. The expansion of space ensures that these distant regions are forever beyond reach. The darkness here has a different quality. It's not just empty. It's primordial. This is darkness from when the universe was young, before most stars existed, before galaxies had formed their familiar shapes. It's the darkness that remembers the beginning. As you float here, at this ultimate edge, space itself is different. It's expanding faster here, much faster. The acceleration of dark energy is pulling space apart, stretching it, thinning it. Every moment, the distances grow larger, the isolation deepens. Eventually, in the very far future, this expansion will isolate everything. Galaxies will drift apart, disappearing beyond each other's observable horizons. Each galaxy will become its own island universe, alone, unable to see or know that others exist. The night sky will gradually, slowly empty. But that's trillions of years away. For now, you float here at the edge. The cosmic microwave background surrounds you. This is the oldest light in the universe, released when the cosmos was only 380,000 years old. It's been stretched by the expansion of space, cooled from thousands of degrees to just 2.7 degrees above absolute zero. It whispers the story of the beginning. in the faintest possible voice. This is as far as light can take us. Beyond this, there's a wall, not a physical wall, but a wall of time. Before the cosmic microwave background, the universe was opaque. Light couldn't travel freely. We can never see further back, never witness the actual beginning. It's hidden behind this veil of ancient light. You're surrounded by the afterglow of creation itself. Every direction you look, you see this faint microwave glow. It's perfectly smooth, almost, with tiny variations, ripples that would become the seeds of all structure, all galaxies, all stars, all planets, all life. The loneliness here is cosmic. You're at the boundary of knowledge itself, the edge of what any observer, anywhere in the universe, at this moment in cosmic history, can see. It's a loneliness shared by every conscious being in the cosmos. We're all trapped in our own observable bubbles, forever isolated from most of the universe. And yet, in this ultimate isolation, there's a strange comfort. You're made of particles that were there at the beginning. Your atoms remember the Big Bang. Remember when everything was together, compressed into a point smaller than an atom. Before the loneliness, before the voids, before the vast expanses of empty space. In a sense, you've never been separated from any of it. The universe expanded, cooled, formed structures, but it's still one thing, one connected whole. The emptiness between things is just the universe giving itself room to breathe, room to think, room to dream. As you float here, at the very edge of everything we can know, you can feel how your own consciousness is part of this vast dreaming. Your thoughts slowing now, matching the cosmic rhythm, the gentle expansion of space, the patient journey of light across impossible distances, the quiet cooling of ancient radiation. Everything is slowing, quieting, deepening. The universe itself is settling into a longer, quieter phase of its existence, and you can settle with it. You can rest with it. You can drift into sleep, knowing that you're part of this vast, quiet, eternal dance. The edge of the observable universe isn't really an edge at all. It's just the limit of now, the boundary of this moment. And like all boundaries, it's meant to be transcended, not by traveling, but by resting, by letting go, by drifting into the deeper cosmos of sleep, where all boundaries dissolve. You're safe here, at the edge of everything, held by the same forces that hold the galaxies, cradled by the same darkness that cradles the stars. You can let go now, let go and drift deeper and deeper into the peaceful darkness, into the quiet, into sleep. And now, very gently, very slowly, we begin our return. Not rushing, never rushing, just a slow, peaceful drift back through all those lonely places, all those quiet spaces, carrying their peace with us. Back through the cosmic voids, those vast bubbles of emptiness that define the shape of everything. Back through intergalactic space, where galaxies float like distant islands in an endless ocean. Back through the quiet zones between spiral arms, where stars burn steadily, patiently, peacefully. Back past the dark nebulae, those cosmic shadows preparing for futures not yet born. Back through the local bubble, our quiet neighborhood in the galaxy. Back past the rogue planets, those lonely wanderers following their solitary paths through the darkness. Back through interstellar space, where the Voyager spacecraft continue their eternal journey, carrying messages from Earth into the void. Back through the Oort cloud, where comets sleep in the darkness, waiting for their moment to fall toward the sun. And finally, here we are, approaching Earth. Our beautiful blue marble, floating in the darkness, but not alone, never alone. Held by the sun's gravity, accompanied by the moon, surrounded by sister planets. Part of a galaxy, part of a cluster, part of the vast cosmic web. Even in all that emptiness we've explored, Earth was always there, waiting for you. Your bed was always there, warm and comfortable, ready to welcome you back. You can feel yourself settling now, settling back into your body, into your bed, into the familiar comfort of home. All those vast distances we traveled, they're still out there. The voids are still empty. The rogue planets still wander. The edge of the universe still expands into the unknown. But you're here, safe, warm, ready for sleep. The universe has shared its quietest secrets with you tonight. It's shown you its loneliest places, its vastest voids, its deepest silences. And in all that emptiness, you've discovered something beautiful. The peace that comes from space, the rest that comes from stillness, the sleep that comes from silence. If you're still awake, still listening to my voice, I want to thank you. Thank you for taking this journey with me, for floating through these cosmic voids, for finding peace in the emptiness. Your presence here, even as you drift toward sleep, makes these stories possible, makes these journeys real. I'd love to know, what did you dream about tonight? What lonely places spoke to you? What vast spaces made you feel most peaceful? You can share your thoughts whenever you wake, in the comments below. Every message is a little light in the darkness, a connection across the void. But for now, for this moment, there's nothing you need to do. Nothing to think about, nothing to worry about, nothing to hold on to. You can just let go. Let go, like those rogue planets, drifting freely through space. No destination needed, no schedule to keep, just the peaceful drift through darkness. Your breathing has probably already slowed, matching the rhythm of the cosmos, in and out, like the universe itself breathing, expanding and contracting in its own ancient rhythm. Your thoughts are becoming like those hydrogen atoms in the voids, floating, occasionally bumping into each other, but mostly just drifting in the vast spaces between. No rush, no urgency, just the gentle drift toward morning. The silence of space is with you now, not the everyday quiet of Earth, but that deeper silence, that cosmic quiet, where even atoms are lonely, where even light takes millions of years to find something to illuminate. That silence is here, holding you, cradling you, inviting you deeper into sleep. You might already be asleep, and that's perfect. That's exactly where you should be, drifting in your own peaceful void, your own quiet space, where dreams form like galaxies in the darkness, slowly, gently, beautifully. But if you're still here, still listening, just barely, know that you can let go anytime. The story continues even in silence. The universe keeps expanding even while you sleep. The stars keep shining. The voids keep growing. Everything continues in its patient, eternal dance. And you're part of it all. Every atom in your body, forged in stars. Every breath you take, exchanging molecules with the cosmos. Every dream you dream, a little universe being born in your sleeping mind. You belong here, in this vast quietness. You belong to the silence, and the silence belongs to you. So rest now. Rest deeply, rest completely. Let the emptiness hold you. Let the darkness comfort you. Let the silence sing you to sleep. The universe is vast and lonely and beautiful, and you're part of it all, drifting now into your own peaceful space, into your own perfect void, where sleep lives, where dreams bloom, where rest is infinite. Good night, my friend. Sweet dreams. Sleep well. And thank you for drifting with me through the loneliest, most peaceful places in the universe.